Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. In this video, we are going to discuss about the different methods that are used for the expression of the concentration. Already we have discussed a few ways by which we can express the concentration in previous video. If you have not watched my previous video, then you can watch that so that you can understand this particular content of this video. If you like the content of this channel, you can subscribe to my YouTube channel. Now let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session. After this session, students will be able to explain the different terms that are used for the expression of the concentration. Already in previous video, we have discussed about the percent concentration as well as the molar concentration. Here you can see there is a difference between molar and molal. Here there is a presence of L, and in molar there is a presence of the R. So in this way you can remember. Now what is the meaning of molal solution? It is the one that contains 1 mole of a solute, that is the molecular weight of that particular substance, per kilogram of solution. In molar solution, we have taken the 1000 ml or 1 liter of a solution. Here, instead of that 1000 ml, we are going to take a 1000 gram or 1 kilogram of the solution. It is represented by small m. Molality of a solution is independent on the temperature, but molarity is dependent upon the temperature, because if we increase the temperature of the solution, then the amount of solute that is to be dissolved, that will be changed, that will be more. So molality is independent of the temperature. Molality can be calculated as m, small m, that is equal to the molecular weight of that substance divided by 1000 gram or the kilogram of that particular solution. In this way, molality is also used for the expression of the solvent. Also, it can be calculated as m, that is equal to weight of a solute divided by weight of a solvent into molecular weight of a solvent into 100. In this way also we can calculate the molality of that particular solution. Here both solute as well as the solvent, they are taken as a weight, not a solvent is not taken as a volume, into molecular weight of solvent into the 100. 1 mole solution, molar solution of aqueous sodium hydroxide, which can be written as 1 small m NaOH, means 1 moles of a NaOH per 1 kilogram of a solution. Then next term that is used for the expression of concentration is normal solution. Normal solution, it is a one that contains 1 equivalent weight of a solute per liter of a solution. Now instead of the taking molecular weight, here we are going to use the equivalent weight of a solute per liter of a solution. In detail I will tell you how to calculate the equivalent weight, but just for instance you can remember it is the one that contains 1 equivalent weight of a solute per liter of a solution. For example, 2 normal solution of aqueous hydrochloric acid, which is written as 2N hydrochloric acid, means there are 2 equivalent weight of HCl per liter of a solution. Also, normality can be calculated as normality is equal to number of equivalent weight of a solute divided by liter of a solution. Here just for instance you can remember the 2 normal solution means what? 2 equivalents of HCl. 1 normal means 1 equivalents of HCl. How to calculate that equivalent weights, that I will tell you. Normality can also be calculated as N is equal to W by 2 into EW into V, where N is normality, weight W is weight of a solute, EW is nothing but equivalent weight of a solute, and V is nothing but the volume of a solution. Equivalent weight of a substance may get changed according to the reaction carried out in between the reacting species, so that normality may get vary. So molarity does not depend upon the reaction, but normality usually depends upon the reaction that is to be carried out. Normality and molarity, these are the two terms basically most commonly used for expression of the concentration. So normality is different sometimes it is equal to molarity. The equivalent weight is generally calculated with the determination of species changes in the resulting reaction. Okay, how to calculate the equivalent weight? Just I will tell you afterwards. Now another term that is used for the expression of the concentration is formal solution, which is also known as the formality. Some substances like sodium chloride, FeCl3, means these are the different inorganic molecules which does not exist in the molecular form, but they remain in the ionic form in the solid state as well as the liquid state or solution form. So for such a substance, a different term is used for expression of the concentration, which is known as the formal solution or the formality. How we are going to calculate for such a substance? Formula weight is used instead of molecular weight for the preparation of the solution. It is represented by F. On changing the volume of a formal solution with temperature, formality of solution may get changed. Formality can be calculated as F, weight of a solute in grams, divided by volume of a solution in a liter into formula weight. So this is about the formal solution. Now we will see how to calculate the atomic weight, molecular weight and equivalent weight of that particular substance, because all these quantities are required while expressing the different concentration terms. First we will see atomic weight. Now you are familiar with what is the meaning of atomic weight. Atomic weight is the average mass of that particular atom that is present in the element, which is expressed relative to the mass of a carbon 12, which is assigned 12 atomic mass. Carbon is having atomic weight of 12. So according to that, different masses are allotted to different elements. Say for example oxygen, this is having 16, hydrogen 1. So these are the atomic weights of that particular element. Also for example sodium, which is having an atomic mass of 23, chlorine, which is having an atomic mass of 35.5. Then second term that we are going to discuss is molecular weight. Molecular weight or the molecular mass is the mass of a molecule. It is calculated as the sum of atomic mass of each constituent atom multiplied by the number of atoms of that element in the molecular formula. Means here, while calculating the molecular weight, we have to consider the atomic weight of each and every atom that is present in that particular molecule. So it is calculated as the sum of atomic mass of each constituent atom multiplied also by the number of atoms of that element. Means suppose one atom is present 2 times, we have to multiply the atomic weight of that atom by a 2. So we have to consider both number of elements as well as the number of atoms. So this is about the molecular weight. Now let's see various examples. For example, sodium hydroxide. Here you can see 3 atoms are present. One is the sodium, another one is oxygen, third one is the hydrogen. So if we want to calculate the molecular weight of the sodium hydroxide, we have to consider atomic weight of sodium, then oxygen and the hydrogen. So molecular weight of the sodium hydroxide is 40. How it becomes 40? Sodium is having atomic mass of the 23, oxygen which is having atomic mass of 16 and hydrogen which is having atomic mass of 1. So 23 plus 16 plus 1, that is equal to 40. In this way molecular weight of that particular substance is calculated. Now equivalent weight. Now there are different ways are there by which we can calculate the equivalent weight. Equivalent weight, first we will see how to calculate the equivalent weight for the acids. One equivalent of an acid is the amount of acid that will furnish 1 mole of hydrogen ions or that will react with mole of hydroxide ions. Now here you can see how to calculate the equivalent weight of acid, molecular weight divided by number of H ions. For example, the molecular weight of HCl is 36.5 gram and it contains 1 mole of hydrogen. So the equivalent weight of acid, it depends upon the number of hydrogens that can be donated, or whatever the number of hydrogens that are capable of reacting with the hydroxide ions. Here you can see number of hydrogen atoms are 1. So that's why here we can write down as a 1. So as HCl is having number of hydrogen ions 1, therefore equivalent weight is equal to molecular weight of HCl, which is 36.5 divided by 1, that is equal to 36.5. The molecular weight of H2SO4 is 92, but here you can see number of hydrogens are 2. So here we have to consider it as a 98 divided by 2, that is equal to 49. Here you can see the molecular weight of HCl and equivalent weight of HCl is same, but as number of hydrogens in H2SO4 are more, that's why molecular weight is 98 while the here equivalent weight is 49. So this is the difference between the equivalent weight as well as the molecular weight. Then equivalent weight for the bases. It is also calculated similarly, but instead of measuring the number of hydrogen atoms, here we are going to measure the number of hydroxide ions. For example, here we can see molecular weight of NaOH, as we know it is a 40 and it contains only one OH, that is the hydroxide. So equivalent weight of NaOH is calculated by molecular weight divided by number of hydroxide ions. So 40 divided by 1, that is equal to 40. For example, here if we want to calculate the molecular weight of aluminum hydroxide, which is having a molecular weight is 78. Now here you can see number of hydroxide ions are 3. So there are 3 moles of hydroxide ions that will react with 3 moles of hydrogen ions. That's why to calculate the equivalent weight of aluminum hydroxide, we have to divide it by a 3. So 78 divided by 3, that is equal to 26. So this is the equivalent weight of the aluminum hydroxide. In this way we can calculate the molecular weight of base. Then how to calculate equivalent weight of salts? One equivalent weight of a salt is meaning that salt that will result from replacement of 1 mole of hydrogen ions of a conjugated acid. For example, the molecular weight of NaCl is 58 and it results from replacement of 1 mole of hydrogen ions of a conjugated acid in this reaction. So here you can see reaction NaOH plus HCl, that is equal to NaCl plus H2O. Therefore, equivalent weight of NaCl, that is equal to molecular weight divided by 1, because only 1 mole of hydrogen ions are conjugated from the HCl acid. So that is equal to 58 divided by 1, that is equal to 58.5. Also we will see another example. Here molecular weight of NaHCO3, sodium bicarbonate, is 84, which results from the replacement of 1 mole of hydrogen ions from conjugated acid H2CO3. Though here you can see, or HCl, though here you can see there is a presence of the NaHCO3 plus HCl, which gives H2CO3, which results from the replacement of 1 mole of hydrogen ion. Therefore 84 divided by 1, it is again the 84. Then molecular weight of sodium carbonate is 106, which results from replacement of 2 moles of hydrogen ions that are from the H2CO3. Therefore the equivalent weight of sodium bicarbonate is equal to the molecular weight divided by 2, which is 106 divided by 2, that is equal to 53. Then equivalent weight of in the precipitation titration, which can be calculated by using formula, the molecular weight divided by valency of precipitating ions. For example, here you can see, here precipitating ion is Cl with the valency that is equal to 1. Therefore equivalent weight of NaCl is equal to molecular weight divided by 1. For AgNO3 similarly we can calculate, where the again